And as we proceed here, you'll see that, and I'll talk about it, but hierarchical linear regression is an extension of multiple linear regression. So a lot of the concepts are exactly the same for multiple linear regression, but I will discuss, primarily where hierarchical linear regression deviates from multiple linear regression. And when we get into a discussion of the assumptions surrounding hierarchical linear regression, we'll briefly cover that, but we won't go in depth and get into SPSS and click on buttons, because you can refer to one of the previous hierarchical linear regression sessions, which I'll point you to, or you can refer to one of the multiple regression sessions where the assumptions are addressed in detail. And that prevents us from going into, over an hour, in a session like this, okay? But that'll make more sense as we move on. So what we're trying to do here this afternoon or this evening, as I mentioned in some of my sessions, if any of you have attended, my main objective is to ease your anxiety, okay, surrounding, this particular test. There's no way in an hour that one can learn everything about hierarchical linear regression. There are actually courses on just the one statistical test. So for example, in our Walden program and in most programs, you'll have a quantitative course, and that quantitative course will cover, 5, 6, 7, 8 tests in one course. But some schools, and I took some advanced graduate work with Penn State, and regression was a 16-week course just in itself. So I'm just trying to set the stage for you. Don't worry about trying to learn and know everything. I'm going to go over the very basics, but what's needed for you to know, to understand, to perhaps get through a coursework assignment or to get through a proposal or a dissertation. Okay, so we're going to cover those very broad concepts. Now, if I could ask, as I always do, if you could just type in the chat what drew you to this session. I like to get, a gauge of the audience, if someone's taking coursework, or if it's just professional development, or if you're contemplating doing it in your dissertation, et cetera. It just kind of gives me an idea of what our audience is here. Can anyone just please kind of type in there, why you're here for this particular session? Okay, Felicia, developing your perspectives. Okay. And perhaps, hierarchical linear regression is the test that you may be proposing. Professional development, dissertation study. Okay. Refresher. Okay, fantastic. Data analysis plan. Okay, and I think everyone will get something out of this. It kind of fits all of those needs. Okay, fantastic. Dissertation, perspectives. Okay, great. Now, and again, we're going to provide a broad overview of the various concepts and applications of HLR. We'll understand how to conduct a hierarchical linear regression test in SPSS. And as usual, I provide some additional resources, and I will point your attention to a very critical survey that you can fill out to help me gain an understanding of your future needs. Okay? So the first thing I'm going to do is overview the scales of measurement. And if many of you have attended some of my sessions, you'll note that that is a topic that I cover in pretty much every quantitative seminar that I conduct because of its importance and really understanding scales of measurement. As you progress through, a quantitative journey, you'll see how it relates and pretty much dictates and drive a lot of things that we can and cannot do. Of course, the conditions for the test, when do we use it, why would we use it? Just briefly cover the data assumptions, but we won't go into detail because that detail can be found in another seminar that I'll point you to. Okay, how do we run it in SPSS? Then, the most important piece is interpreting and understanding what we have just done, instead of just saying, I had a significant finding. Really, what does all this output mean? Because the more we understand that, the more we are better able to start writing, say, our discussion section, our chapter 5, or whatever program you're in, and whatever that discussion section is, you'll see how important it is to understanding this output and how to interpret that, okay? Because you're gonna have to take that and put it into English language, into words, okay? And we'll be able to do that after this session. And then again, of course, how do I write that up? the results of a hierarchical linear regression test. Okay, we'll revisit some resources, we'll summarize what we've done, and then we'll take a quick look at the anonymous and voluntary survey. Now, the first thing I wanted to do was cover the scales of measurement. Okay, when you're in SPSS, again, you're going to have, for every variable that you have, you're going to have to identify a scale of measurement for that variable. And that scale of measurement is so important. I mean, there's some tests that we cannot run if data is a certain scale of measurement. And so it's really important to understand that. And there are 4 scales of measurement, and you'll see the nominal, the ordinal, the interval, and the ratio scales of measurement. Now, what is meant by that is that nominal is a categorical variable, okay? For example, gender. Gender is categorical, meaning, male or female, or you may have high or low, or it may be, any other type of data, yes or no, something categorical. It may be ordinal data, a Likert scale, a scale of 1 to 5, rate your agreement with this, I agree, strongly agree, disagree, etc. Then you get into the higher order numbers, which are interval and ratio, okay? But in SPSS, you won't see the words interval and ratio. What you will see is the word scale. And so if your data is either an interval or a ratio scale of measurement, you would select scale. So there are the 4 scales of measurement covered, okay? And there's some more detailed, actually a whole seminar I did on scales of measurement, if you want a more broader review of that information. Now, concepts. What is hierarchical linear regression? Well, the first thing I want to talk about is because it is some concepts. You don't just select a statistical test just because you want to select a test. You have to think about your methodology. You have to think about your gap in the literature. You have to think about a lot of things. Now, one of the things we know in research is that, we are measuring something. We want to measure it as accurately as possible. We want to make sure that what we're measuring is truly what we said we're measuring, etc. But we know that there's always noise that impacts our results. And what is noise? Noise is an unmeasured third variable. And this third variable influences or confounds, a relationship that we're looking at between 2 variables. So that's why we say, a simple correlation test is really not sufficient for a doctoral project. Running a simple Pearson's correlation, because you're only looking at 2 variables. And we know that there are a plethora, 100,000 other variables that can influence that relationship. But we can't collect data on all of those. We have to do what we call a parsimonious approach to research, meaning not too many variables, but enough to give us some understanding of a topic. Okay? Now, what we can do is decide to remove that noise. And one of the ways we remove that noise is with a control variable, okay? We can remove that noise with a control variable. And what happens is that when we remove noise, we increase our signal, okay? Does that make sense? We get a better output. Our measurement is more accurate. We know we have removed the influence of something, especially if we're not concerned with that. Does that make sense to everybody? Because this is important. You're going to have to talk about, why are you doing a hierarchical linear regression? What are the conditions for that? And this is what you want to understand, that you're trying to remove noise from your study. Now, the noise reduction will increase your signal. But what is this variable also? It is not a variable of interest to you as the researcher. But from your research, your literature review, you know that this variable has some influence on your dependent variable. You know that from the literature, okay? And what you want to do is say, my position is that I want to control that noise, okay? I want to remove it from my study. Now, we don't just select the variable just because we want to select the variable. That control variable should be related somewhat to your dependent variable. And that's understood from the literature too. And it is not an arbitrary decision. You don't just say, I'm going to look at the relationship between A and B and control for C. Well, your literature review should support that control variable being there. Why? And it should be some evidence that it is somewhat related to the dependent variable, and we want to remove that noise, okay? So explain why you have selected the control variable. Does that make sense to everyone before we move on? Fantastic. Okay, thank you for that, Lighty. Yes. So again, you want to make sure that you're understanding why you've chose a control variable. Because if you don't really base it on the literature, there's a great possibility that when you run the analysis, you'll see that this control variable was not a predictor or even related to your dependent variable. Okay? And what you're trying to do is select something that you know is related and remove that noise. That is the groundwork for why you are doing that. So when you're talking about this in your study, a control variable, these are the types of things that you should be addressing and providing support and rationale for why you are doing that particular test. Now, so then that leads us to exactly what hierarchical linear regression is. We can predict, same thing as in multiple linear regression. We predict the value of a scale. Remember when we looked at SPSS, it had to be interval or ratio? Dependent variable. Okay? Based on the values of one or more predictive variables after you control for one or more variables. Okay? So the difference between multiple linear regression and hierarchical linear regression is that the hierarchical linear regression allows you to control for one or more variables. Multiple linear regression does not. Does that make sense to everybody? Fantastic. So if someone says they're looking for relationships and controlling for something, you know, if that dependent variable is scale, then more than likely HLR or hierarchical linear regression is the appropriate analysis. Okay? Now, and again, it's a statistical technique and it answers that predictive research question, just like we talked about in multiple linear regression. For example, you may want to know what is the relationship between optimism, self-esteem, and these are predictive variables, okay? Because remember from multiple regression, we talked about that word and that I have bolded, underlined, is a very critical word. Because if you look down at my little note here, the word and separates your predictive variables from the dependent variable. So we know that optimism and self-esteem are predictive variables because we always state the question in temporal order. What we mean, the predictive variables come first, and then what follows is the dependent variable, life satisfaction. So this person, if they were conducting a study, their problem, their introduction to their study would be talking about life satisfaction or the lack of satisfaction, the negative impacts on life, or whatever the case may be. Now, then they're going to control for age. So this person is saying that from the literature, they saw that age is related to life satisfaction. Okay. But they want to remove the influence of age and just see if optimism and self-esteem are predictors. Are we still on the same page here? Everyone feeling okay? With conceptually what we're doing. Fantastic. Because it's going to be important when you see this and you see this left side and this right side, it'll all start making sense once we start looking at output and how we conduct the analysis. Now, here's an example. Let's examine that research question again carefully, just as I have done. X1 and X2 are the predictive variables. Again, Y is the dependent variable because it follows the word and and then after controlling 4, and then we have the C control variable, and always presented in temporal order. Predictors first, then dependent variable, okay, after and. Now, here we go. Just as in regression, there's something called residuals, and it's all about the residuals. And what do I mean by that? Let's go through an exercise so that we can know exactly what we're talking about. Now, I have a number written down, and that number is from 1 to 10. I've written down a number, okay? And what I want you to do is to use your psychic abilities, and now you're going to guess. You're going to predict. Remember, we said that this is a prediction test. Now, what I'd like for everyone to do that wants to participate is in the chat, predict the number that I have written down on a piece of paper, ranging from 1 to 10. Okay, I see some numbers there. Thank you for that. Now, what I want you to do is I'm going to type my number in here that I predicted. So, oops, excuse me. So check into the chat. My number, the true number, the observed number is 8. Now, what I want you to do is take the difference between your number and my number. Don't worry about negative signs. Just do the absolute value. What is the difference between what you guessed and my true value of 8? Okay, Shawnee is 3, Felicia 0, 5, 4. So it looks like Felicia was right on point, okay? Now, that difference number that you have just typed, that second number, that is called the residual, okay? That is the difference between the observed or true value of the dependent variable. In this case, we assume that it was 8, my number, and your predicted value. Does everybody see that? The difference is the residual. Now, if you're trying to predict something, would you want a lower or higher residual value? What would you want? Fantastic. You want a lower residual value. And we're going to look at these models when the output comes and start examining this from a residual perspective to know how good or how bad the model predicts. Now, late last night, I decided to do something here just to give you another example. Because what I want you to understand is conceptually what you're doing, because this is what you have to write about. What is the regression test? Why do you do it? You know, what's the purpose of it? Now, here's a map of the US. And down here in the bottom right is where I live in Florida. Okay. And I'm right up here near Jacksonville in a little city called St. Augustine. And during the hurricane season, of course, we are worried about hurricanes coming up this Atlantic coast. Now, every morning I get up, one of the first things I do since I moved to Florida is I look at the news during hurricane season to see what they're showing, what's predicted. Is anything coming from that western coast of Africa where things usually start and work their way, you know, all through the Caribbean islands, et cetera, and then come somewhere to the US. Now, you'll see on the news that those news reporters or those, what do they call them? Geologists, or not geologists, but the weather people, you know, and they will show you these plots, these lines. They call them spaghetti plots. And each one of these is a prediction of where the hurricane is going to hit. Now, obviously, we want what? The best predicting model possible. A lot of things rely on that. The safety of meteorologists. Thank you, Shania. Everything relies on that, safety, protection of people, rescue missions, do we evacuate people or not? We have to be as accurate as possible. So that's the concept of regression. We're trying to predict some outcome, and we want to be as accurate as possible. Does that make sense to everybody? Without even going into SPSS and looking at stuff, that's conceptually what you are trying to do. So now, in the chat, can you type perhaps what is the variable? What are you trying to predict? if you are doing, perhaps or either thinking about doing a quantitative study that uses regression. What are you trying to predict? What is the dependent variable? What is your problem of concern? Or that you may even be thinking about? What would that be? Mine's was, I wanted to be able to predict career decision self-efficacy in adolescence from a set of predictive variables. What are you trying to predict? That's my variable. What might you be trying to predict? What is your dependent variable, your problem? Now, you may not be there yet, so that's fine because I don't see anyone typing anything. But again, that's the concept. You're going to have a problem variable, a dependent variable that you have to predict, okay? Now, assumptions. Any what we call parametric statistical test is a test. When we say parametric, it has data assumptions that come with that test. And what do I mean by that? A data assumption is a characteristic about that data. Its shape, its spread, it's something about that data that if it's violated, it changes conclusions, output, interpretations, etc. In other words, it's a bad thing if it happens. Now, in real life, it will happen, okay? Now, what do we do though? First thing we have to do in a proposal is say, the hierarchical linear regression comes with 8 assumptions. We identify what those 8 assumptions are. Then there are processes and procedures in SPSS where you assess the assumptions. In other words, does my data meet these characteristics that it should meet? Okay? I have to then tell the reader what were the results of those assumption tests. Did I pass or did I fail? If I fail, what action will I take? I take that action, then I run the regression test. Does that make sense to everybody? We're going to take a look at the assumptions here, but we're not going to go in depth because, again, when you get to presentation, you can go here to this webinar that was conducted previously, if everyone can see that. And when we get to the assumptions, you'll see that I have a very detailed explanation on assumptions. Does everybody understand how we're going to proceed with that? And this will cut a whole hour off of what we're trying to do here this afternoon or this evening. Everybody understand that? Okay. So now, fantastic. So now, what are they? Remember, dependent variable needs to be interval or ratio. But this is a design issue. You wouldn't select a variable if it's not that. It has to have a sufficient sample size. That's when we do an a priori power analysis. We calculate how many we need. We do all of this. Now, when we get into SPSS, these are the ones that we assess in SPSS, okay? We want to make sure, assess outliers, multiclinearity, all of these here, linearity, normality. But the thing I want to point out about these, remember we talked about its residuals? You are examining residuals when you assess these assumptions, not the raw data. I had an appointment with a student this afternoon, one of the research doctoral appointments, and the individual had a very good study, doing a very good job. But as the individual was assessing the assumptions, the individual was saying that the dependent variable was non-normal. And I told the individual, you're not looking at the dependent variable solely. What you are looking at, if you're looking for normality or linearity, you're looking at the residuals, okay? The residuals. And we're going to learn how to do this. But this is important that you understand that, okay, my study is about regression, predicting, and I need to understand residuals. In other words, how bad was my prediction? How good was my prediction? The residuals is what's critical, okay? So you're not looking for normality or linearity of one piece of data. You're looking for residuals. And remember, residuals are a difference between true and predicted values. That's a big difference, okay? But now, let's look at this in SPSS and talk about this. Now, the first thing is that we're going to look at the research question that we'll examine. And again, is there a relationship between optimism, self-esteem? Remember the word and. Here comes the dependent variable. And here's the control variable, age. Okay? And just simply transfer there is, oh, excuse me, there is not. Okay, there is not a relationship. Excuse me. The null is always the hypothesis of no difference. So let's just go ahead. There is no statistically significant. Yeah, there we go. There is no, and there is a. Okay? The alternative is always there is. And what we're trying to do is find evidence to reject this one, okay, and accept this one. That's what we're trying to do. Reject this one to say there is no relationship, and hopefully be able to accept the alternative and say there is a relationship. And we can do that when we see that the p-value is less than 0.05. And we'll look at that. Now, don't worry about this because you'll have this slide to go back to. I have other resources, but basically what you would do is analyze. Of course, you have all of your drop down. You're going to do regression and you're going to do linear. This is the same thing you would do with multiple linear regression. No difference. Okay. Now, once you do that, you'll get this linear regression dialog box. The same thing you get for multiple linear regression. But this is where things differ. Now, dependent variable, remember we said that was life satisfaction. We want to predict life satisfaction. But notice in here, I only have one variable, that's age. But I've got two other variables, optimism and self-esteem. Where are they? Well, do you see up here, block 1 of 2? Does everybody see that? I want to get some confirmation here. 1 of 2. Does everybody see that? Block 1 of 2. This is where your control variable go. Control variable or control variables. It doesn't matter. Okay? Because what happens is the first thing you have to do is evaluate your control variable. Is this variable statistically significant to a predictor of my dependent variable? We have to do that. We have to ascertain, the status of the control variable. Now, what happens is you click next, okay? When you click next, what will happen is you will get block 2 of 2. And this is where your predictors go. Okay? So in a well-written proposal, you're going to tell the reader, I have, life satisfaction is my dependent variable. Optimism and self-esteem are my predictor variables, and age is my control variable. In SPSS, I will enter the control variable age in block 1 of 2. You see, in your proposal, you're telling the reader what you're going to be doing. You're telling yourself how to do this. And all you're going to do when you get the data is do it. Okay? That's all you're doing. Okay? Give me just a second. Let me let someone back in here. Okay, so you see that block 2 of 2, and then that's where your control variable goes. And then block 2 of 2, excuse me, your predictor variables. Is everybody okay with that? Okay? And yes, I'm still screen sharing here, so everyone should still be able to see that. Everyone still see the presentation? Yes, okay. Thank you. Now, that's it. What will happen then, here are some selections you can make, and I would say as a minimum, select these, okay? Always select the confidence intervals for 95% and select these. Now, what's important, you see this R² change? Why that must be selected is because now you're doing hierarchical linear regression. The first model, which is your age model, your control variable, is going to calculate an R² value. It's going to calculate that. The second model, which are the predictive variables, are also going to add above and beyond the first model. That's why we want to know how much does the R squared change from the first model to the second model. Does everybody understand that? Now, to better understand that, let's take a look at that. Now, I'm going to blow this up as big as I can here, okay? Give me just a second to really get this screen big for you. Now, model summary is a piece of output of concern. Now, notice we have model one and model two. The model one line is where you put in the control variable of age. Now, tell me, look at this, and as you can see, age, right here, if we look at the sig value, was age a significant predictor in this model? You tell me. From the chat, was age a significant predictor? What would you say? No, it wasn't. Now, when I add the predictors in model in the second block, remember block 2 of 2, what happens to the model? What has happened to the overall model? Now, it's become significant. Yes. Now, but notice we don't see anything about the individual variables or coefficients here. We don't know that, but this just lets us know how the R squared or the F value changed from one to the other. Now, what's important now, perhaps a good bit of information, is the ANOVA table. Now, model one, we know, was not significant. Okay? And again, model two, with the addition, it was significant. This is the important one here that helps us, coefficients. Now, in the first model, again, age was not significant. Now, in the second model, when we control for age, was age significant at that point in the second model? When we included it, did age provide any significant contribution? No. Age was not a significant contributor. It was not related to the dependent variable, and the researcher may have chosen perhaps not an appropriate variable, or perhaps the literature did suggest that, but this researcher found something different. We don't know. But now, what happened to both of the predictive variables? Did they both provide significant predictability? Yes, they did. Yes, they did. So from this, you see your control variable added no significant value to the prediction, but then when we control for that and added the predictors, we got a significant model. That's all that means, and that's what's happened. Now, the important thing is, now how do I write that up? How do I write that up? And let's take a look at this. And as you can see, this is kind of very similar to multiple regression. And so we're going to kind of take our time here, and look at this. And, because there's a lot of eye work here. We got to look at this and look at that. Now let's take a look at this. So the first thing we're going to say, we conducted HLR, right? To look at that relationship. Almost as a repeat of the research question, okay? Then we know we have to assess the assumptions. Here is an example where the assumptions were not violated. We just stated that for training purposes, okay? We conducted those preliminary analysis to assess those assumptions. And these are the assumptions, and we assume that no violations were noted. Okay, now we can go on and do the analysis. So for example, if you noted that you had outliers, you may go back into the data set and remove that outlier or those outliers, you see, and then run the analysis. I don't know, but that's a little bit above and beyond what we're trying to do here, okay? But now let's look at how we write this thing up. how we can understand a research study when we read it now, a regression study, a hierarchical linear regression study. So we notice, remember age, remember was entered at step 1. Remember we said that block 1 of 1, age. So the reader knows that step 1 is the control variable. In other words, model 1 or step 1. It doesn't matter, but we said step 1, and it was insignificant. We know that, right? No significant value in the age model. No, nothing. 195, and then when we combined it, it was 0.295 or something down here. It wasn't significant, okay? But now we have to put the statistical notation. That's this piece. Give me just a second. That's this piece right here. F1, 431, 1682, blah, blah, blah. Now, F, we know that the regression creates an F statistic. We know that. Here it is right here, F, okay? It creates an F statistic. That's what we're going to report, that F statistic. But before that, we have to report some other information. Now, if anyone was in the other regression sessions, anyone want to take a stab at what that 1 represents? That 1 right there. Anyone want to take a stab at that may have attended the regression session, the other regression session, what that 1 represents?
Degree of freedom.
Degrees of freedom. What does degrees of freedom mean?
Okay. So it's the number of variables minus 1. So sometimes.
Okay, the 1, exactly. The 1 lets us know that there was 1 variable in the model. And what was that? That was age. Excuse me. That was age. Right here. First model. 1 variable was age right here. That degrees of freedom right there. 1. This is the first model. 431 right here, degrees of freedom. See the 431? Anyone want to take a grab at that?
Number of cases.
Exactly. But it's a formula. Number of cases minus 1. So the true sample size is right there, 432. Now, when you look at a regression study right now, and as we read them and we read all of the literature review and this and that, and then we get here and this is where we stop. We don't understand this. This is the most important information. You can't critically analyze a literature without understanding this. Were the results significant? How was the variance? Because you have to compare your results to this when you complete it, in your chapter 5 section. Now, let's just then, all we're going to do is transpose the 1.682 from right here, 1.682, okay? So all we've done was taken information from the ANOVA model, the 1, the 431, and the 1.682, and transpose it over here like that. Does everybody see that? Yes, no?
Yes.
Okay. Then we just simply report the sig value. Right here, 0.195. Explaining less than 1% of the variance in satisfaction. Where does that come from? 1%. Remember, R squared is the measure of effect size for multiple regression. But if I take, to get the percentage, remember from our math days, we moved the decimal point 2 places to the right. 0.4, that's less than 1%. Not a lot of variance. Doesn't explain a lot. And we know that because it's not significant. Now, but after entering the predictor variables at step 2, remember in SPSS, block 2 of 2, the total variance explained by the model, let's look at the second model, was 0.304. It went up 30%. It explained the model was 30%. Now, again, here, 3. See in the model here, the second model, the 3. What does that 3 mean? Anyone?
Variables.
Yes, 3 variables in the model, and here they are. 1, 2, 3. 3 variables in model 2. Okay? Now 3, again, 429. We look now, see here, 429 in the second model. The F value, 62.476. And the sig, less than 0.01, comes from right here. So you're reporting this and this for the first model, and you're reporting this and this, all this for the second model. Does everybody see that? And then we say in the final model, which is this last one down here, all variables were significant except age. You see that? Age was not significant. And optimism, right here, recorded the highest beta value, right here. You see the beta value? Does anyone remember from regression what that beta value is? Because we're going to talk about these slopes in a minute. But let me do that now. The other important piece. Now, the next important piece, or one of the most important interpretations of multiple regression, are the unstandardized coefficients, or what we call slopes. Every variable has a slope. Remember, from our algebra days, a slope is a change in y over a change in x. So if we change x age, how much will y change? So what this means is for a 1 unit increase in age, a 1 unit increase. So say going from age 35 to 36, that individual's satisfaction score will go down because it's a negative by 0.027. Does everybody see that? Does everybody see that? So basically, as we get older, this is saying our satisfaction goes down. Does everybody see that? Because this is what you really now are going to turn into words and talk about this. Okay? Now, what happens for every 1 unit increase in optimism? What happens to satisfaction?
It increases by 0.484.
Bingo. What happens to total self-esteem?
Increases by 0.4.
Bingo. So you see, as these values change, go up or down, how they impact the dependent variable. You can predict. Okay? Now, slopes. The next important piece are the standardized coefficients. Now, we know that things are measured on different scales. We know age is measured differently from optimism, from satisfaction, etc. These are different metrics. But what this does is take these metrics that are different and kind of standardizes them, make them all in the same playing field. And what it allows us to do is to see which predictor is the strongest. Not which slope goes the highest, but which one is the strongest based on the absolute value. Don't worry about the negative or the positive. So which one of these predictors has the strongest predictive value in here? And I said it right here, optimism with the beta of 0.318. You see that? Because it's a little bit higher than 0.315. Does everybody see that? Does this output now make a little bit more sense than it did perhaps 30 minutes ago? And do you think you'd be able to take the output and create an APA results write-up? Remember, the difference between this regression and regular multiple regression is that you have 2 models. The control variable model and the model where you added everything. Okay? It tells you that right there. It even tells you that right here. Model A, You see the little A here? Look down here in the footnote, the A. That predictor was age. Don't worry about the constant. In model 2, we put age in, total self-esteem, optimism. So just get comfortable with looking at the charts and the graphs or whatever, and just taking your time and understanding. But you see, once we understand the conceptualization of HLR, we can understand what we're looking at here. Do you understand what I'm saying there? If we didn't know controlling and putting them in different blocks and looking at the SPSS piece of it, it may make it difficult for us to translate that to what's going on here. But does everybody see that connection again?
Yes.
Okay, great. Now, the other thing that I'm going to give you, and I'm going to put that in the chat, is going to be this. Come on. Come on, where are you? There we go. Okay. This document I'm going to put in the chat to you, okay? And this is just an example. I just put something together here called an hierarchical linear regression, an application exemplar. You know, it just kind of just talks about here what HLR is, what we've talked about, etc. And then, you know, I have a little forward here. And then an example research question, what we just did. Optimism, self-esteem, and satisfaction after controlling for age, what the hypotheses would look like. So, for example, you know, if I was taking a course and my faculty said, "Hey, this week you're going to run hierarchical linear regression," you know, and if it's no template there or something specific, report the results or write the question. This is kind of what it would look like. These were the results we just looked at. Remember all of this? Remember one variable in this model here. Sample size -1, non-significant model here, less than 1% of the variance. When we added the other two, you see here, now we got the 3 variables. This is the sample. The F, you see how the F value increased to 62.7 from 1.62? That lets us know it's a better predictor. That model was significant. Again, here's the R squared. 30% of the variance, remember, because we removed the decimal point 2 places to the right. So about 30.4% of the variance. Both predictors, not the control, but the predictors provided a contribution, and we put the beta weights. See that here, descriptive statistics table and a regression summary table. And all of this is just information right from the SPSS output. Okay, right here is what you're seeing, SPSS output. Remember the beta weight, the slopes. Remember the standardized here. And then this is just how much the R squared increased. And you'll be able to just translate this right back to the output. Does this make sense to everybody? A little bit more sense now of what hierarchical linear regression is, the conceptualization of it, what you need to consider when you get into SPSS, and then how to put the write-up together.
Dr. Tello, please, I have a question.
Yes.
So assuming that we did not have 2 models, talking about noise and age as, probably causing the noise, assuming we all threw everything in as in multiple regression, what effect would that have had in the result?
I have no idea. You would just run it and see what the results are. That I don't know, because it's a whole different analysis. Now, for example, let me see something here. Here's SPSS, okay? So
Okay.
I'm going to go analyze. Let's just do it. Regression, linear. Okay. The dependent variable was satisfaction, and I had optimism, self-esteem, and age. You just have 3 predictors. You don't have control variables. So we're just adding this. Let's just see what the model looks like now. Give me just a second. I don't need the R squared change because I'm not doing a hierarchical linear regression. Okay, so let's just take a look and see what happens. Okay, now here's the results. Let's take a look. You tell me. Is the overall model significant? The overall model, is it significant?
Adjusted R was the I see looking. Yeah, it is. No,
And how would you know that? Okay, the ANOVA, exactly. The overall model.
Yeah.
Okay. Now, let's look at the three. Remember, only one model. Optimism was significant. Self-esteem was significant. Age still provided no predictability.
Not significant. Okay.
Exactly. But see, that's just it. Your study is going to be based on the gap in the literature. Is your gap saying that you have seen this relationship, but you have not seen where age has been controlled? That determines what you do. The gap. Or if you didn't see a study that looked at these three together, I don't know. But again, you got to determine your methodology and your reasoning for doing what you're doing. And usually that's a theory-based decision. Okay? But yeah, but that's what you would do. You can see how it changes. So basically the data is saying the same thing. This still is not proven to be a significant predictor. Here, 0.205. Okay? And these two are optimism. You see, all that pretty much stays the same there. Yeah. But it's letting us know we controlled for it in one and we didn't for the other. So we included age as a signal instead of treating it as noise. Does that make sense?
Yeah.
Yeah, that's what you did there. So that depends on your design. What are you trying to do? You know, are you trying to control noise? Or are you trying to control noise? Are you trying to increase signal? Or are you trying to do both? Increase signal by adding another variable and then adding a control variable. I mean, it's options. And that's something that I'm going to, let's move on here. And that leads us to something here, these resources here that I'm going to point you to. Okay.
Can I ask you a question, please?
Sure, go ahead.
So I came a bit late, I'm sorry. So I just want to understand the term controlling for. When you say you're controlling for.
Okay, I'm running out of time here because you came late though, but a control variable is a variable, and I'm going to send you back to the slides that you can write here. It's the noise reduction. It's not of interest. And you want to control it because it influences the outcome. That's a control variable. Okay, and you decide that you want to control for something. In this example, we controlled for age. Okay, and it's all a literature-based decision. Why did you choose age? Some people may say, I'm going to control for gender. I don't know. Whatever that control variable is, why? And it should be based on literature. Okay?
Thank you.
And you're trying to remove noise if that's what you're trying to do. Now, what you'll have here is we're going to go to this link of all the seminars that I conduct. Remember, I told you how important scales of measurement is here. Layered statistics is something that goes over multiple regression. It just doesn't do the hierarchical part. And then here is another video that I did on multiple regression, but that will go in depth with the assumptions also. Okay, the assumptions will be there. Okay, so let's do something right quick here. I'm going to take you out here to the ORDS webpage is what I want to do now. And because, you know, your question, one of those questions was about noise and control variables, etc. But I'm going to show you something here. When you go to the ORDS webpage, all of these are the seminars that I have conducted. Okay. Here I did one earlier last year on hierarchical linear regression. Okay. That one, I believe I went all the way through the assumptions, but if not, go to one of these multiple regression ones and you'll see everything about the assumptions, okay? There's the scales of measurement video seminar. If anyone's conducting secondary data analysis, this is something you need to look at. But what you can do is as you visit this page, you'll see tomorrow night, well, this is tonight. Tomorrow, I'm doing one on binomial logistic regression, okay? Next week, I'm doing one on the chi-square test. Okay, so make sure that you bookmark this page here to always check this schedule. And then now, if things go successfully, this session, hopefully I hit the record button, this session here that we're doing tonight will show up down here as a recording. Does everybody see that? So you'll be able to see and go over everything again that we did tonight. And that's kind of how this process works. So the first thing I'm going to do is take this, and that is still the same link that's in the on the slides, but I'm going to now put that into the chat, okay? So the org link is in the chat. All righty. Now, the next thing that I was going to take you to was Leard statistics, okay? Now, this website and again, it's in there in the link, in the slides, but as you can see, this is linear regression, same thing that we just did. And I'm going to show you that the only difference was, you see here, they're going to take you through an example and they're just going to put in one independent variable. But all you would do, the only thing that would differ, you know that in block 1, you would put your control, you'd hit next here, and in block 2, you put your predictor. But all the assumptions that we talked about, all of the output, let's look at this. Tell me what happened here in this example. Is this a significant model?
Yes.
Yes, it is. You see sig is 0.000. Let's see what's going on here. Okay. How much the dependent variable is, I'm not sure what it is here. But whatever it is, that dependent variable, how much would it increase with a 1 unit increase in income?
0.564.
Bingo, whatever that unit of income is, okay? Exactly. Oh, it's price of something. So that price, let's just say if it was in dollars, would increase by 0.564, 56 cents or something like that, But anyway, as you can see, that this is all very helpful information. So this link, I'm going to put also in there, but again, it's in the slides, okay? But just the more the merrier. Okay? That's in there, okay? Now, the other thing that I did want to show was the question came up about noise and things of that. This here is a very good seminar that I would recommend individuals, especially when you're starting your dissertation, designing robust research questions, okay? And that goes into understanding what we call signals, noise, but also how to increase noise. How to decrease noise, how to increase the signal. Some of you have heard of, doing a regression test where you have a moderator variable? Have you heard of that? Moderation? It's something, perhaps you could use age, but not as a control variable, but you could have perhaps used age as a moderator or a mediator. This one gets into discussing all of that and how to build a robust research question. You don't need 2, 3, 4 questions. You can have one good, robust research question that controls noise, increases signals, et cetera, et cetera. So that may be a very helpful one to look at also. But my point is that bookmark this and check this periodically to see, and you don't have to wait till that email comes to you from whoever or however you received it. You have your pass to checking and knowing anytime anything is coming up. And if you miss something, that next day, that recording should be here, okay? So there were over 200 and something people that registered for this seminar. Obviously, they're not all here, but hopefully tomorrow, that 100 and something people will be able to come here and see on-demand quantitative seminars and see this hierarchy of regression session that we did tonight on 30 January. Does everybody see how this is working? Okay. So even when you see something, if you can't attend it, check back and the recording should be there within the next day or so. Okay. Now, having said that, I'm going to go back to the PowerPoint, and I really would appreciate it if you would take the time to go to this survey. Okay, when you get the chance, you'll get the slide. Okay, just give me a second here. And I don't know how. Okay. And it takes about 10 minutes to complete. And what it'll be here is something this, oh, excuse me. And this would be the survey here that I would appreciate you take a moment, to fill out. Let me know where you are in your doctoral journey, et cetera, what seminar that you attend. You'll see that they'll be listed here, the seminars. In this case, I have to add the hierarchical linear regression, okay? But as you can see, how many of you attended and blah, 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 all this information. But here's where you really get the chance to tell me what you think, what you need. Did this work? Does it not work? Do you want more? Et cetera, et cetera. This has been built based on the feedback that I have received. I did this a couple of terms ago and put a survey together, and it's been built based on what I get from this survey. Okay, this is your tool. You're building this resource, not me. A lot of times we think we know what you need and feed it to you. I'm giving you the opportunity to tell me what you need. Okay, so I would really appreciate you taking the time, to fill that out for me. And other than that, I don't have anything else. But what we did, remember, we looked at those 4 scales of measurement, very critical to understanding statistical analysis. Okay. We went over the hierarchy of regression. We know it is very similar to linear regression, but the difference is that it allows us to control for a variable or more than one variable. Those are the conditions. We know we have to assess assumptions. We went through the procedures, and the main thing is, remember, block 1 and block 2. We know now how to look at some output and interpret it, and how to turn that output into a compliant APA write-up. We looked at some resources, and you know where the survey is. I thank you for your time and attendance this afternoon. I'm hoping that this has been very, very beneficial to you. And I always like to ask the question before I end. We go back to the very, very first slide, second slide. Did we ease any anxiety?
Yes, you did.
Fantastic. And that's what it's about, easing the anxiety. And I know now that each and every one of you will be able to go back and say, okay, I understand a little bit better. Now, you're not going to be an expert. You may have to ask additional questions, but you have a broad overview now of what you're trying to do. And I'm hoping that everybody has gained something from this seminar. Okay? So
Dr.
now,
Carlo, could you share your PowerPoint, please?
yes, that's the next thing. I'm getting ready now to take these documents, and give me just a second here. Okay.
And the exemplar, please.
Yes, I am. Give me a second here. That's what I'm doing now. So just let me focus here. Okay, let's put that one in there now. Okay, now if you would check the chat at the very bottom, it should be the HLR PowerPoint. Does everybody see that?
Yes, thank you.
Okay, now I'm going to put the word exemplar in there. So just bear with me. I'm gonna just have to save these documents to places and make sure I know where they are. Files, save a company. Okay, everybody, checking in. Now make sure that the word HLR exemplar is in there, okay? Everybody see it?
Yes.
Got your
Yes,
PowerPoint?
thank you.
Okay, and that's it. I think you have everything you need to get going. And I really think that you'll benefit from this, but please check out those other resources. Any questions come up about a concept, just check that site to just see if there's anything out there that may be on that topic. And you can save yourself a lot of time, and effort and headaches, because my job is to put these resources together for you and to have them available out there for you. Okay. So I'm gonna go ahead now and I'm going to mute myself and step away. I'll leave the classroom open for a few more minutes if anyone wants to get any of the documents out or, review anything that was done in the chat, okay? But again, thank you so much for your time and attendance. And again, if I'm correct, tomorrow evening, I'll be doing the binary logistics regression, okay? And I hope to see you then. If you haven't registered, go out to that OLS website and register, because you'll need a registration link for that one, okay? My friends, you take care until we meet again. And you know where I'm at, and resources are here, and don't frustrate yourself. Reach out to ORDS and let us help guide you through your journey, and let this be a very, very positive experience for you. That's our job, okay? And hopefully I'm doing a good job doing my job. But anyway, take care, have a great evening, and enjoy the seminars, and look at all those videos, and make sure you get all of the resources out of this chat that you can. Okay, thank you, and have a great evening.
Thank you.
You're very welcome, my friend.